Hello, in this lesson, we're going to talk about whether an argument is valid or not based on a truth table or maybe using a standard form approach, which is question 2. And then in question 3, we're going to use Euler's diagram to determine whether it's valid or not. So 3 approach. First one is truth table, second is standard form, and third is Euler's diagram. Let's do question 1. Question 1 asks to write the following argument in symbolic form and then determine whether the argument is valid or invalid using a truth table approach. Again, notice that it says using truth table approach. Now, in the class today, I noticed a lot of you done it using standard form. Make sure you read the direction to be clearly and do as the direction asks. So let's do the before I do a truth table, I need to write the argument in notation form. So let's kind of identify my premise 1, 2, and 2. So first one is if I'm going to run the marathon, then I will buy new shoes. Second premise, if I buy new shoes, then I will not buy a television. So those are my premises. Those is the one I'm going to write it down into the argument. So before that, I need to represent with some notation first. Let's let R for I'm going to run the marathon. Okay, R represent I am going to run the marathon. Okay. Next thing I'm talking about is buying new shoes. So I'm gonna let B represent buying new shoes. So I will buy new shoes. Okay. So here notice that we're talking about running a marathon, buying new shoes. And next thing talking about is whether to buy a television. So I'm gonna let T represent buying a television. I will buy a television. A television. Okay, once I've done that, I notice that I have 3 simple components here. So that means I will have 2 to the 3rd power of rows, so which is A rows is needed. So for my number of rows, I will need A. Now, so I'm going to list out my components are B, R, T, and the A rows in the truth table. So let's write the argument in symbolic form first. So let's write it. So in symbolic form, I have, so first one, the first premise, it says, if I am going to run a marathon, so notice that it's an if and then, so it's a conditional statement, so first premise is conditional statement. If I am going to run a marathon is R, running a marathon is R, then I will buy new shoes. Buying new shoe, we say, let B to represent buying new shoes, so B. That's my first premise. Second piece, okay, is also a conditional statement. It's a if I buy new shoes, then I will not, again, here's a not, buy a television. So again, if I buy new shoes is B, buying new shoes. Then I will not buy a television. Again, T is buy a television. So negation of P will be not buying a television. Negation of T, so N of negation of T. Now, therefore, the third my conclusion. Notice that therefore, this tells me this part is starting with the conclusion. So draw a bar. I say, therefore, my conclusion. I will, if I buy a television, again, notice if and then, I will not run the marathon. So if I buy a television, again, buying television is T. So T implies that I will not run the marathon. Not running the marathon. Run the marathon is R, so not run the marathon will be negation of R. So that's my argument. So my goal here now is to determine whether this argument is valid or not using the truth table approach. So let's list my table. We said we're going to need A row. So let's write down my simple components. RBT, I'm going to write out RBT. So again, in standard form, we say half first component, half true, half false. So true, true, false, 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 false. The second component alternate every true, 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 false. So true, true, false, false, true, true, false, false. The last component alternate half the previous one, which is true, false, true, false, true, false, true, false, and then true, false. And the next one is my first premise. So this is the first premise. Let's call P1 for my first premise. P2 my second premise. So my P1 is over here. So I'm going to write the first P1 out. So it's what's the premise 1? Is R implies B. My second premise is B implies negation of T or not T. And this is P2. The conclusion is T implies negation of R. So T implies negation of R. And that is my conclusion. Now, on the right hand side, this little empty space I draw in advance here, I just want to do good for labeling. Here it's going to call row 1. So row, so this is my row 1, number of rows. So I'm going to call 1, 2, 3, 4, 5, 6, 7, 8. And once I've done labeling, this is here. It's not like you have to do it. I'm going to label just for easier discussion. So let's complete the true table now. So recall that conditional statement is only false if I have true followed by false. Then the true value is false. Otherwise, it's always true. So let's remember that. So let's write down my values. So I'm going to put it here. So the first one is true. I'm going to just bring on the R value. True, 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 false, 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 false. Bring the B over. True, true, false, false, true, true, false, false. Once I've done that, it's just conditional. So again, so I have true, true is true. Let me use the same color here. So true, true is true. This is true. True, false is the only one that's false. True, false. So this is false. True, true, and then true, true. I'm going to make that my column 1. Okay, just for easier discussion. I'm going to do the same thing for the second column, the second premises. Oh, this should be a second premise, not 1. The second premises. So here I'm going to do the same thing. So B is true, true, false, false, true, true, false, false. Negation of T. T, true, false, so false. True, false, true, false, true, false, true. Again, I'm going to do the conditional part again here. So true, false is false. So this is false, true, 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 false is false. So true, true, true. And I make that column 2. I'm going to do the same thing for the last, my conclusion column. I'll bring the T over, so which is true, false, true, false, true, false, true, false, true, false. The R column is negation of R, so it's false, 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 true, 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 true. Now I'm going to complete conditional again. So true, false is false, so this is false. True, true, true. Oh, hold on, I have a true, false right here. So be careful here. So this is false. So true, 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 and that is column 3. I just complete the true table. Now, how do we determine whether the argument is valid using the true table? Remember, recall that we said whenever the both premises are true, the conclusion must be true. So I only consider the rows where the both premises are true. So let's identify the rows where both premises are true. So let me highlight it. Both premises true here is row 2. Okay. Premises also true in row 6. Both premises are true. 7, 8, 9. Now, of all the row 2, 6, 7, 8, 9, for all those on A, for those rows here, both premises true. That means the conclusion had to be true to be a valid argument. So now let's check the conclusion. So for the conclusion for the here I have true. Okay, good. Both, this is also true, true, true. So since whenever both premises is true and the conclusion is true, this is a valid argument. So let me write a conclusion. Since whenever, when now, both premises are true, the conclusion is also true. I'll say this is 0, so C rows 2, 6, 7, 2, 6, 7, 8, and columns 1, 2, 3. Okay, so just a little note for myself. Therefore, so since it's true, this is a valid argument. This is a valid argument. Note again, recall again here, I only consider the rows where both premises are true. I didn't consider row 3, 4, 5 here. I don't even need to, right? 1, because the premises here are not both true. And if I have in the conclusion part for rows 2, 6, 7, 8, if any one of those, the conclusion is false, you will make this an invalid argument. Okay, thank you for watching. I'm gonna for question 2 for the second part of the video.